Hello everyone, my name is Ying Zhao, and I'm the Manager of Client Support Service at Bruker Arxspan. Today, I'll be walking you through a tutorial on linear ligation and insertion cloning using our BioDrive platform.
This video will demonstrate linear ligation and insertion cloning. At first, we'll ligate two linear DNA sequences to create a new linear DNA sequence. Then we will insert the newly created linear DNA sequence into a circular vector to create a new plasmid. This is the BioDrive landing page. The user has two ways to upload DNA sequence. The first one is you can drag the sequence file from the folder directly into the loading windows, and the sequence will be loaded. Or you can use the choose file function and then pick the file, and the sequence will be loaded. Now we have two linear DNA sequences in the tool, and then in the sequence you will notice for the GFP protein we have a NOT1 restriction site at the 3', and on the 5' of the COVID spike protein, we also have a NOT1 restriction site. We're going to use this site to ligate these two linear DNA sequences together. So from the Create drop-down menu, select Linear Ligation. And then the tab you are on is the GFP protein, so that will be used as the fragment 1. And then we select the enzyme. So there is an enzyme you can select from the drop-down here, or you can use the search function, search NOT1 from the enzyme list and select it. And now let's move to fragment 2. So in fragment 2, you have option to choose which DNA sequence to use. So we're going to use the COVID-S, and then we are doing the same thing. Go to search for NOT1. And now if the two enzymes are not compatible, it will be red. So when they are become compatible, it's become blue. And now you can go to the product tab. You can see the GFP protein is from the fragment 1 is highlighted in blue, and the COVID-S sequence are highlighted in orange. And then here we are showing how the ends are ligated together. And then we will click the ligation button, give a name. So now we created a new linear DNA sequence which contains the GFP protein and also our target DNA sequence. If you look at this DNA sequence, you can see there is a ACC65-1 cutting site on the 5', and also a SAL1 on the 3'. Now we can initiate the insertion cloning from this tab. And then then let's go to the fragment 2. So that's our insertion, and then fragment 2. So currently I don't have a circular DNA sequence in the 2, so we're gonna similarly you can drag a circular DNA sequence into here, so you can see the circular map. And then in this, it's Park 19. And then here is the multi-cloning site. If you look at the sequence map, you can see the ACC65-1 cutting site here, and also the SAL1 cutting site here. So now let's go back to fragment 1. We're going to pick the ACC61 from here. And we'll pick the same enzyme for fragment 2. And then in fragment 1, we're going to use the 1. And similarly, And now let's go to the product tab. So you can see the new product is also a circular plasmid, and then it have all the original features from the PAC19 vector, but then we insert our target DNA sequence in here. And also, if you look at down the insertion fragment panel, we are showing how the two restriction enzymes are gonna ligate together. So now click the clone, give a name. Great. Now we are generating the new circular DNA sequence. Similarly, you can see in the new product in a full view.